Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on linear algebra chapter row space and column space of a matrix, lecture number 14, in which I will solve some problems to find the linearly independent vectors through the concept of row rank of a matrix. Now we solve a problem. Problem is so that vectors capital X1 is a order triplet 1, 2, 3. Capital X2 is another vector order triplet 2, -2, 0. Form a linearly independent set. Now we solve this problem with the help of row rank of a matrix. Let us form a matrix in which rows of the matrix will be the component of the vectors. Let A be matrix. The first row of the matrix will be the components of the first vector 1, 2, 3. Second row will be component of the second vectors 2, -2, 0. This is a 2 by 3 matrix. Let B equal to submatrix 1, 2, 2, -2, 1, 2, 2, -2. Determinant of B equal to -2, -4 equal to -6. This is not equal to 0. Therefore, determinant of a square submatrix B of order 2 gives non-zero value. Implies that rank of matrix A equal to 2. We know that rank of a matrix equal to row rank of the matrix. Implies that row rank of matrix A equal to 2. We know that maximum number of linearly independent row rows of the matrix is the row rank of the matrix. Here row rank equal to 2. Therefore maximum number of linearly independent rows equal to 2, that is the two rows of matrix A are linearly independent. Implies that vectors x1 equal to 1, 2, 3 and x2 equal to 2, minus 2, 0 are linearly independent. Proved. Now we solve the next problem. Next problem is show that vectors capital X1 is order triplet 3, 1, minus 4. Other vector X2 capital X2 is order triplet 2, 2, minus 3 form a linearly independent set. Now we solve this. Let us form a matrix in which rows of the matrix will be the components of the vectors. Let A be matrix, first row be the components of the first vector 3, 1, minus 4 and second row be the components of the second vector 2, 2, minus 3. This is 2 by 3 matrix, 2 rows and 3 columns. Let B be a submatrix in which elements of the first row be 3, 1, in the second row 2, 2. Here determinant of B equal to 3 multiply 2, 6 minus 2 multiply 1, 2. 6 minus 2 equal to 4. 4 is not equal to 0. Means determinant of the submatrix B of order 2 is not equal to 0. Means this determinant gives non-zero value. Therefore, rank of the matrix A will be 2. Since we know that rank of a matrix equal to row rank of the matrix, therefore row rank of the matrix A will be 2. We know that maximum number of linearly independent rows of the matrix is the row rank of the matrix. Here row rank is 2. So maximum number of linearly independent rows of this matrix A be 2. That is the rows of the matrix. Here we have 2 number of rows. Means rows of this matrix are linearly independent. This implies that the vectors x1 containing components 3, 1, minus 4 and vector x2 containing components 2, 2, minus 3 are linearly independent. Therefore, vectors x1 containing components 3, 1, minus 4 and other vector x2 containing components 2, 2, minus 3 form a linearly independent set. Now we solve the next problem. Next problem is show that vectors x1 is order triplet 1, 2, 3. Vector x2 order triplet 3 minus 2 minus 1. Third vector is x3 order triplet 1 minus 6 minus 5. Form a linearly independent set. Let us form a matrix in which rows of the matrix will be the components of the vectors. Let A be that matrix in which first row be the components of the first vector 1, 2, 3. Second row be the components of the second vector 3 minus 2 minus 1. Third row be the components of third vector 1 minus 6 minus 5. This is a 3 by 3 matrix. Number of rows be 3 and number of columns be 3. Now we find the determinant of matrix A. Here we see that determinant of matrix A is not equal to 0, means non-zero determinant. Therefore, determinant of the matrix A of order 3 gives non-zero value. That means rank of A equal to 3. We know that rank of a matrix equal to row rank of the matrix. Here rank is 3. Therefore, row rank of matrix A equal to 3. We know that maximum number of linearly independent rows of the matrix is the row rank of the matrix. Therefore, maximum number of linearly independent rows of this matrix will be 3, because here row rank of matrix A is 3. That is, the rows of the matrix A are linearly independent. This implies that vectors x1 containing components 1, 2, 3, vector x2 containing components 3 minus 2 minus 1, vector x3 containing components 1 minus 6 minus 5 form a linearly independent set. Proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button, and if you have not yet subscribed my YouTube channel, then please subscribe my YouTube channel. Thank you.